Differential Equations, Section 2, Analytical Solutions. Video 3, Families of Solutions. The set of solutions of a differential equation gives a family of curves that can be described and investigated using the techniques from the investigation of curves topic. So when we were looking at investigation of curves, we were looking for things like stationary points, symmetry, asymptotes, and so on. We can do all of those things with the solutions that we get when we look at a differential equation. Let's go back to the example dy by dx equals 2y that we looked at when we were looking at tangent fields. I can use my CAS window to solve this. So I want to solve the ODE and I want dy by dx, so y prime equals 2y. Space for multiplication there. And it solves it and it gives me the general solution y equals c1 e to the 2x for some constant of integration c1. So let me plot that in the graphics window. Y equals c times e to the 2 times x, and I've got it to give me a slider for c, and I can see now the family of solutions and start looking at what's common to all of them and what changes between them. So the first thing that I might comment on then is that as x tends to negative infinity, y is tending to 0, so that means that the x-axis is an asymptote of this curve. I might look for intersections with the axes. Now it's not going to intersect with the x-axis, but there is a point of intersection at the y-axis. So e to the 0 is 1, so at x equals 0, y is equal to my constant c. So if I put that up to c equals 2, you can see the point of intersection at 0, 2. And if I took it down to c equals -1, you can see the point of intersection is at 0, -1. I might also want to comment on the fact that there are no stationary points for any values of c here, and I can think about why that is by differentiating this and seeing that I would get something of the form 2c e to the 2x, and if I solve 2c e to the 2x equals 0, that is only going to be 0 in the case c equals 0. And that is this trivial solution here to the differential equation when I get the constant line y equals 0. So here are two of those examples. My general solution is y equals a e to the 2x. I've used the constant a this time, and I've shown it for a equals -1 and a equals 2. So this is the case a equals -1 here, and this is the case a equals 2. And these are outputs from GeoGebra, but I could just as well have sketched these graphs using all of my curve sketching techniques. And the sort of things that I might note down is that the x-axis is an asymptote. I might notice that it intersects with the y-axis at the point 0, a, and I might also note that there are no stationary points. In this video, you've learned how to apply techniques from the investigation of curves topic to families of solutions to differential equations.